What's up, team? Today we're talking degrees and radians and converting back and forth. Learning target right here. I can convert an angle measure in degrees to radians and vice versa. So let's do a little bit of quick review. This is something we learned recently. We know that if we have the central angle over 360, if we have that ratio of whatever our central angle is over 360, so for example, this triangle would be 60 over 360. To find the arc length, we would create this as our unknown and divide it by whatever the circumference is. So we talked about this in the previous video. So this same formula can be kind of summarized a little bit, made a little simpler. If we call our central angle M and our arc length S, we can condense our formula a little bit. M over 360 equals S over 2 pi r. Of course, the 2 pi r comes from the circumference formula. So we'd have to plug in the radius here. And then I solved it for S. So what I did is I multiplied both sides by 2 pi r, and then I put the S on the other side. So S equals 2 times pi times r times m divided by 360. It's a little bit gross, so we could simplify it ever so slightly, because 2 divided by 360 is 1 over 180. So we have r times m times pi over 180. So if we have the radius and the measure of that central angle, all we have to do is plug those two pieces of information in, and we'll have our arc length, which again we've called S. Okay, so this is review, and then we've condensed it and kind of created a little formula, which we are going to use here in a few minutes. Okay, I want to examine these three circles. These three circles have a lot in common. They have a lot different. Notice that they all have this 60-degree central angle, and they have different radii. So this one's got a radius of 1, this one has a radius of 2, this one has a radius of 3 units. Made a little table. We're going to fill it out and look for patterns. So circle A has a radius of 1. And to find the arc length, we're going to plug the information that we have into our formula over there. So S, I'm going to call it S sub 1 because it's the arc length of the circle with radius 1. We know our radius is 1. The angle measure is 60, and pi is pi. And then our denominator, following our formula over here, is 180. Simplified, we get 60 divided by 180. Well, that's 1/3. And so pi is what's going to be on top. So we have 1 pi over 3. So the arc length over here, this length on circle A, is pi over 3. If you plug that in your calculator, you get a decimal approximation a little bit over 1. I'm going to leave it as pi over 3 for the time being. Okay, and then this is a ratio that I want to explore, the arc length divided by the radius. Arc length divided by radius. So what we're going to do is we're going to do pi over 3 divided by our radius, which is 1. Well, in this case, anything divided by 1 is 1. That one's nice and easy. So this one's just going to be pi over 3. Okay. Let's do the same thing for circle B. Circle B has a radius of length 2, and we're going to find the arc length using this same exact formula. This time we're going to call it S sub 2. So our radius is 2, our angle measure is still 60, pi is still pi, and 180 is still what's in our denominator. Well, I'm noticing here that there's still the 60 over 180, just like we had a moment ago. So I'm going to reduce the 60 and the 180, but I'm not going to touch the 2. I'm going to leave it there. I'm going to leave it be. So on top, we're going to have 2 pi. And then the 60 and the 180 turn into 1/3. So I have a 3 in our denominator. So our S sub 2, the arc length right here of our second triangle, is going to be 2 pi over 3. And in the same way, we're going to do a little bit of division with some fractions. This one's going to be a little bit messier, so we have to remember a trick from something we learned previously. So arc length is going to be the 2 pi over 3, and I'm trying to divide 2 pi over 3 by the radius, which is 2. And of course, that's the same thing as 2 over 1. So when we divide fractions, what is it, keep, change, flip, or something like that? So what we're going to do is we have 2 pi over 3 times 1 over 2. These 2's cancel, and we end up getting pi over 3. So the ratio of the arc length to the radius is pi over 3. This will come into play. I know that this part seems weird. This will come into play, so hang on. Okay, same thing with our third circle. Radius is given to us. It is 3. And we're going to do the same business over here. We're going to find the arc length. So I'm going to call it S sub 3 again. Following our formula. 2 times our radius. In this case, it is 3. Oh, hang on. I'm following an old one. I want to follow the one here in the box. My mistake. So our radius here is 3. Our angle measure is still 60. These all share that 60-degree angle. Pi is in our numerator. The denominator is 180. Similar to both of the other ones, the 60 and the 180, they have a relationship. 60 over 180 is 1/3. So I'm going to leave this 3b, the one on top. I'm not going to touch it. There's a pi here. And then 1 over 3 turns this into 3. All right, this feels funny. We're going to go with it. So 3 over 3, they cancel out. And we learn that our S sub 3 is just pi. Great. Now our arc length divided by our radius on this one, a bit simpler. It's just going to be pi, because it's not a fraction, divided by radius over 3. So it's pi over 3. Okay, look for patterns now. Of course, as the radius gets bigger, the arc length is going to get bigger as well, because the circle itself is getting larger. And you can see pretty clearly, this is 1 pi over 3, this one's 2 pi over 3, and this one is 3 pi over 3, which is what we had, and we simplified. So that makes sense. As the radius gets bigger, the arc length also gets bigger. But notice that this relationship between the arc length and the radius, so this ratio, is always pi over 3. That's always going to be the case for any sector you ever explore, any arc length you ever explore, where the angle measure is 60 degrees. So this is a special ratio that we'll talk about moving forward. This is called the radian measure of that particular angle. So we say that a 60-degree angle has a radian measure of pi over 3. Radian is a word we haven't used at all in our course. This is that button on your calculator. Sometimes you have it in the wrong mode on accident. It's in radian mode. It might say a little R-A-D. We're going to start to explore that a little bit. So the rest of this lesson, we are just going to practice converting degrees into radians and then radians back into degrees. Okay, hang on a sec. I'm going to set this next part up. All right. So if we want to convert degrees to radians, we're going to use the following formula. It's going to be m divided by 180 times pi. And in this case, m is our angle measure in degrees. So if you have some angle measure in degrees, divide it by 180, multiply by pi, and that's how we would refer to it in terms of radians. To convert radians to degrees, we do 180 divided by pi, so pi is in the bottom here, and then we multiply that times r. And r in this case is our angle measure in radians. Let's practice 3 of each of these and wrap this up. Okay, our first one, we're converting these into radians. The first one is 60 degrees, but I want to see it in radians. So we're just going to do 60 divided by 180 times pi. 60 divided by 180 is 1/3. So we'd say that this thing here is pi over 3. Done. Pi over 3 radians is the same as 60 degrees, which matches up to the example that we just did. Next one, 270. So this one we're going to do 270 divided by 180 times pi. Gosh, this reduces a little bit. Let's try to figure it out here. 30 goes into the top one 9 times, but into the bottom one, oh man, I should have checked this one out a little bit closer. So I'm grabbing my calculator. 270 divided by 180, and it's 1.5, so it's 3 over 2. Yeah, that makes sense. 90 goes into both of those. Duh. Okay, so it's going to be 3 times pi on top over 2. 3 pi over 2. This last one, 75. 75 over 180. I'm going to throw that in my calculator. And, oh, I get something a little bit gross. I'm going to cheat. I'm going to use a different calculator that's going to give me a fraction. ends up being 5 over 12. So it's 5 pi over 12. So that's telling us that 5 goes into this 10, 15 times. So 15 goes in each of these. Okay, cool. All right, so that's how to convert from degrees to radians. Let's flip it around. Let's go in the other direction. Now we're going to plug these in to this other little formula down here. So it's 180 over pi times pi over 5. The pi's conveniently cancel out here, which is going to happen every single time you convert to degrees. You're never going to have a pi in your degrees. That's just not going to be a thing we encounter. Pi's cancel. Now it's just 180 over 5, which is 36 degrees. 5 pi over 6. We're going to do 180 over pi times 5 pi. 5 pi over 6. Pi's cancel. So now our numerator is 180 times 5. My calculator tells me that's 900, and we'll divide that by 6. And this is a 150 degree angle. So yeah, 5 pi over 6 radians is the same as 150 degrees. This last one, 3 pi over 2, 180 over pi times 3 pi over 2. Pi's cancel. 180 times 3, 540, divided by 2. And we learn that this is 270 degrees. That makes sense because just a moment ago we started with 270 degrees and got 3 pi over 2. Now we're going the other direction. This kind of demonstrates that our formulas over here are valid. You can go back and forth if you're following the right direction. Okay, your practice problems for today, you have just a couple problems asking you to convert from degrees to radians and then from radians to degrees, just like what you see right here. Okay, let's dive into those practice problems. Let me know if you have questions. You got this.